This is a tutorial for the Moon Observing Lab. Moon observing works differently from most other labs. Instead of doing all of the work in one block of time, you'll need to do your observations for a few minutes a day over the course of at least a couple of weeks. As a result, you'll want to do this one while you're also working on other labs. The first step in observing the moon is finding out when it will be in the sky. The time the moon rises and sets changes each day. It can be up in either day or night. Most of the time, it's up for part of both. So the first step is to find out when the moon will be up. A simple online search for moonrise and moonset times will tell you when you should be looking. Note that often the moonrise time will be after the moonset time. This means that the moon is really up over midnight. So look for it either in the morning before the moonset time or after the moonrise time. The times the moon rises and sets get later by an average of just under an hour each day. So you won't be able to keep observing at the same time throughout the cycle. The moon is bright, so you don't need to find an especially dark site to see it. So long as you have a clear sky in the right direction, you should be able to see it from almost anywhere. In the daytime, you can see it so long as it isn't too close to the sun in the sky. When the moon is in the sky, it moves from east to west, just like the sun does. So if the time is a little after moonrise, look for the moon just above the eastern horizon. If it's a little before moonset, the moon will be above the western horizon. Between those two, it should be higher up and more to the south. If you're observing in daylight, the moon may be harder to spot. Take your time and let your eyes scan around the right part of the sky. If you think the moon may be close to the sun, it's okay to wait for a few days until they're farther apart. Don't stare at the sun trying to find the moon. Once you've spotted the moon in the sky, you can make your observation. The table in the lab lists all of the information you should collect. Write down the date and time, don't forget AM or PM. Also include which town or area you're observing from. Then list the moon's phase. There's a chart above the table to help you identify the phase. You should give the direction to the moon. Is it east, west, southwest, etc.? Many phones have a compass app you can use to help you with directions if you're not sure. We'll describe how to measure the sun-moon angle in the next slide. Also make sure you include some comments about the observing conditions, how easy it was to do the observation, or anything else that you found interesting. The one slightly tricky bit of this observation is the sun-moon angle. The idea here is for you to estimate how far apart the sun and moon are in the sky. You're going to list this as an angle in degrees. When both the sun and the moon are in the sky, the easiest way to do this is to point at the sun and the moon at the same time. Just point one arm at the sun and the other at the moon. It's okay if people look at you funny. You'll get used to it. Then you estimate the angles between your arms. Remember that 90 degrees is a right angle, and 180 degrees means your arms are pointed in exactly opposite directions. You can compare to a protractor if you need a reminder of what different angles look like. This gets more complicated if the sun is below the horizon. In that case, you have to estimate where the sun is based on the time of night. Remember that the sun sets in the west, so if it's just a little after sunset, then the sun will be just below the western horizon. If it's later on, close to midnight, then the sun will be nearly straight down. And if it's in the early morning hours, just before sunrise, then the sun will be a little below the eastern horizon. So again, point one arm at the moon and the other arm down where you think the sun is below the horizon. Estimate the angles between your arms and record this as your estimate of the sun-moon angle. It's okay if you're inaccurate to as much as 10 or 20 degrees. The point is that you're observing for most of a lunar cycle, so you'll be able to identify the pattern through all of your observations, even if individual observations aren't perfectly accurate. And remember, you're measuring from the sun to the moon, even if you must estimate the location of the sun, not the horizon to the moon. As you record your observations, you should also include the moon's location on the moon orbit diagram. You'll use the sun-moon angle for this. On this diagram, the Earth is at the center, and the big circle represents the moon's orbit. The sun is represented by the rays of sunlight approaching from one side. Mark the location of the moon on this circle for each observation you make. The larger the angle you measured, the farther away from the 0 degrees mark you should make the point, up to a maximum of 180 degrees on the far side of the circle from the sun. Remember that you can measure the angle both clockwise and counterclockwise from the 0 point. In addition to marking the moon's location, include the date of your observation, the sun-moon angle, and the phase. As you observe over several days, you should see the moon moving gradually around the Earth on this diagram. It shouldn't bounce around a lot, though it may do that a little because of the uncertainty in your estimates of the angle. Over time, this means that the moon starts out on one side of the sun, the top or bottom half of the circle, and then switches over to the other side. Once you've got at least 8 observations spread out over a couple of weeks, you can finish up your lab with a summary paragraph. The main idea with this final paragraph is that you should explain in your own words what causes the phases of the moon. Think about what part of the moon is lit up by the sun and how our view of this changes as the moon orbits around us. You should also talk about how your own observations relate to this. Be specific about what you saw on some of the dates and how that relates to the moon's location in its orbit and what time of day it was up. Finally, say a little about the observing process itself. Did it all work the way you expected? What surprised you and what didn't? And what did you learn from all of this? Note that we don't have an exploration experiment required for this assignment. But if you've got an idea for one that relates to moon observing, you're welcome to give it a try. Make sure you talk it over with your instructor first.